Good morning, students. So today we will talk about the covalent bond in chlorine atom, chlorine molecules, nitrogen, oxygen, and dissimilar molecules, dissimilar atoms also like water, ammonia gas. Okay, let's talk about covalent bonding in chlorine. So what is covalent bonding? The bond which is formed by sharing of electrons. Now let's see in case of chlorine. We have talked about covalent bonding in case of carbon. Let's talk about chlorine. So electronic configuration of chlorine is 17, that is 2, 8, 7. The atomic number of chlorine is 17, 2, 8, 7. Now chlorine have how many electrons in outermost cell? 7. 1, 2, 3, 4, 5, 6, 7. It is not an octet. So it combines with another chlorine atom having 7 electrons in outermost cell. You can see 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. But to complete an octet, it requires one electron. But chlorine being a non-metal, okay, it does not gain one electron. It can gain one electron in case of any compound also, but here it combines with another chlorine atom and form chlorine molecule. Also it can take one electron from metal like sodium and form any compound, but when non-metals like chlorine and chlorine react, it is forming covalent compound. Okay, covalent compound are formed by between two nonmetals. So in this way, this electron is shared by both chlorine. Now it is having 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Sorry. So in this way, chlorine molecule is formed. Now let's talk about oxygen molecule. So electronic configuration of oxygen is 8O16. So 2, 6. How many electrons are there in outermost cell? Oxygen have 6 electrons in outermost cell. 1, 2, 3, 4, 5, 6. Always remember, in case of bonding, we will talk about only of valence electron. What is valence electron? The electron present in outermost cell. Now, oxygen wants 2 electrons more. So it combines with another oxygen atom in this way. You can see. So here a double covalent bond is formed between two atoms. You can see this. This is the 2 electrons are shared. Here one more electron was shared. Here 2 electrons are shared. So actually it is forming Cl plus Cl. Here it is forming 2 bond between oxygen atom, because now 2 electrons are shared. So this is known as double bond. So double bond is formed here between 2 oxygen atoms. In this way, oxygen molecule is formed. The oxygen which we breathe in is actually O, and also these electrons can be shown here in this way. Okay, these were participating in the bond formation. This were not. These are called lone pair of electrons. Okay, now let's talk about nitrogen. Electronic configuration of nitrogen is 7, and that is 2, 5. So nitrogen have 5 electrons in outermost cell. How many require? 3. So it combines with another nitrogen, and you can see 8 electron in this way, 8 electron in this way. But here 3 electron pair are shared between 2 nitrogen atoms. Okay, these are known as lone pair of electron which do not take part in bond formation. So nitrogen have 3 triple bond between 2 atoms. So these are called covalent bonds. Okay, oxygen is having 2 bonds. Chlorine is having single bond. Nitrogen is having triple bond. So this was about covalent bonding in case of chlorine, oxygen, and nitrogen. I hope you understood this. You have to remember the electronic configuration, and then you have to take just show the valence electron and the bond formation. Okay. Now let's talk about hydrogen, and then we will talk about water and methane, ammonia. So always remember, covalent bond is formed between non-metals. Metal never form covalent bond. Okay, only non-metal covalent bonding or sharing of electrons. Let's talk about hydrogen. Hydrogen is having one electron. Electronic configuration of hydrogen is 1. It has one electron. Other hydrogen has one electron. So both share and form H2 molecule. Now it is having duplet structure. What is duplet structure? Maximum electron is 2. So this was about similar atoms like hydrogen, hydrogen, chlorine, chlorine, nitrogen, nitrogen. Now let's see covalent bonding between dissimilar atoms. Dissimilar atoms like hydrogen, like water. Hydrogen have one electron, another hydrogen have one electron. Oxygen is having 6 electrons. You can see oxygen atomic number is 8. That is 2 6 electronic configuration of oxygen. In case of hydrogen, 1 electron, 1 electron. It requires 1 electron to form duplet structure, and oxygen requires 2 electrons to form octet structure. Just look over here. 1, 2, 3, 4, 5, 6. Now this electron is shared by hydrogen. Hydrogen become 1 plus 1 duplet. It is sharing, okay, it is not completely given to the hydrogen. Okay, 1 plus 1 duplet. Now hydrogen is having 2 electron, and on the other hand, oxygen is having 8 electron. 1, 2, 3, 4, 5, 6, 7, 8. So it is now having octet configuration. So we are going to learn in this chapter probably or the next chapter that this sharing is unequal sharing because of electronegativity concept. In case of similar atoms, electrons are shared equally, like hydrogen, hydrogen. Both atoms will attract the electrons in a, we can say, equal way with a equal force. But when oxygen is strong here because of 8 protons and 1 protons, this topic which we are going to discuss in the next chapter. That this sharing is unequal sharing and becomes polar covalent bond that partial charges produce. But you just remember, this type of sharing of electron is known as, in this way water is formed. Okay, it is covalent bond, and this was what water. Hydrogen 1 electron, oxygen 1, 2, 3, 4, and this 1 electrons, both 1 electrons are using bonding with hydrogen. These are called lone pair of electrons. Lone pair of electrons do not participate in bond formation here. Okay. Now let's talk about ammonia. Ammonia is a gas. Formula of ammonia is NH3. And nitrogen is having electronic configuration. Okay. Electronic configuration means arrangement of electrons around the nucleus of nitrogen. Nitrogen is 2 5. Atom number is 7, 2 5. So we are going to deal with the you can see this 1, 2, 3, 4, 5. Now it reacts with hydrogen atom by sharing of electron. Hydrogen require 1 electron to form duplet. Another hydrogen require 1 electron to form duplet. Now in this way you can see it get attached with 3 hydrogen, and these are called lone pair of electron. Lone pair of electron which do not participate in bond formation. So each bond with hydrogen, 1 electron on this side. Okay. So this was about ammonia. Let's talk about methane. again let's write electronic configuration of carbon. Carbon is 6 to 4. Electronic configuration of hydrogen is 1. Now let's just draw the 4 outermost electrons, and each hydrogen requires 1 electron to form nucleate structure. So you can see this 4 hydrogen, and this sharing of electron is known as covalent bonding. So in this way methane is formed. Methane is a gas. So this was what covalent bonding. But this bond are strong. This covalent bond are strong, but intermolecular force is weak. Which means what? This due to this sharing of electron they are close. But for example, if there is another methane molecule, one methane molecule, second methane molecule, so the interaction between the intermolecular force, एक मीथेन दूसरे मीथेन मॉलिक्यूल के बीच में जो फोर्स है वो बहुत वीक है. That's why the boiling point and melting point is low. So methane, or we can say any covalent compounds, the intermolecular force are very much weak. That's why they have low melting point and low boiling point. But this covalent bond within them, like CH, this is a strong. That's why they keep we can say too close to each other. And always remember that what are chemical bond? There is no such line. The closeness is because of the force of attraction. So the force of attraction is known as chemical bond. And if the force of attraction is due to the electrostatic force of attraction, that is ionic charge, then it is called ionic compound, ionic bond. But if the force of attraction is due to the sharing of electron, then it is called covalent compound. I hope you understood. Let's now talk about the physical property of covalent compound. Physical property. Physical properties of covalent compound. First, physical state. So the covalent compound are having like some NH, like compounds like ammonia, then chlorine gas, hydrogen gas, sulfur dioxide gas, then we have nitrogen gas, oxygen gas. These all are having covalent compound. They are gas, and some are liquid like benzene, ether, okay, etc. They are liquid. And some are solid like iodine. Okay, so you can remember this. Some covalent compounds generally they are gas in state. Mostly covalent compounds are gas in state. Some are liquid also, and some are solid too. Okay, if they are solid, they are not hard solid; they are brittle solid. Second, their melting point and boiling point. Melting point and boiling point are low. Why? Melting point and boiling point depend on the intermolecular force, and intermolecular force of attraction in case of covalent compound are weak. The bonds which are formed is strong comparatively, but the intermolecular force, एक मीथेन मॉलिक्यूल दूसरे मीथेन मॉलिक्यूल का जो इंटरेक्शन है वो weak है. That's why their melting point and boiling point are weak. Is low. Melting point and boiling point are low. In case of ionic compound, it is high. We are talking about covalent compounds. Covalent compound. Next, let's talk about electrical conductivity. Electrical conductivity. So, electric current जो पास करता है, उसको हम कहते हैं गुड कंडक्टर. जो इलेक्ट्रिक करंट पास करेगा, जैसे कोई भी मेटल ले लो, वो पास करेगा, दैट आर गुड कंडक्टर. But plastic is a bad conductor, wood is a bad conductor. So, electric current कौन पास करता है? Those who have free electrons. Metals have free electrons, or in the solution if we have free ions. So when we talk about compounds, this compound they do not have free electrons. So when they don't have free electrons, that's why they don't conduct electricity. Covalent compounds are poor conductor of electricity. Poor conductor. Solubility. They are not soluble in water. Water is a polar solvent. They are soluble in soluble in non-polar solvent. Non-polar solvent. Like salt and sugar get dissolved in water. But covalent compound they do not dissolve in water. They dissolve in non-polar solvent like chloroform. Chloroform is CHCl3 the solution. So it is a solvent in which you can dissolve covalent compounds. Then benzene is also can be used. What else? Then we have. Okay, this was about solubility and thing. Okay, so covalent compounds are true molecules. When you see the lattice, they are form of atoms and molecules. When you talk about ionic compound, NaCl, NaCl is a molecule, but it is not formed by atoms. When we define atom, a molecule, it is made up of what? Atoms. But when you talk about ionic compound, they are made from ions, and the ions are close because of the electrostatic force of attraction. But when you talk about covalent compounds are actually true molecules. In which sense? Because they are made up of atoms. So covalent compounds are referred to as true molecules because they are composed of atoms. On the other hand, ionic compounds are composed of the closeness of the ions. Okay, that's it. If you have a doubt, you can ask me. So this was what covalent bonding in case of non-metals and physical property of covalent compounds.